Hi, in this video, I'm going to look at with you how to solve equations that actually have trig in them. So for the first one, we are going to be finding all of the solutions between 0 and 2 pi. So you can see that here at the end where it says if 0 is less than or equal to theta is less than 2 pi, or it could be written as the bracket was 0 to 2 pi with the parenthesis. So this first problem is sine of 2 theta equals cosine of theta. So I'm not verifying to try to make the left side match it. I'm trying to figure out which values of theta would make this true. The first thing I would probably do is try to get my angles to match. So I'd change my sine of 2 theta to 2 sine theta cosine theta equals cosine theta, and then just to make it easier to solve, pretty much a rule all the way through, like there's more than one trig function happening, I'm going to want it to equal 0. So I'm going to have 2 sine theta cosine theta minus cosine theta equals 0. If this had been something like, I don't know, 2xy minus y equals 0, you might see it a little bit differently, but I am going to be factoring out just like I would here. So what I can factor out of both of these terms is a cosine of theta, which leaves me with 2 sine theta minus 1, and I now have two things being multiplied to equal 0. So I'm going to take each of those factors and set them equal to 0. So cosine of theta equals 0, 2 sine theta minus 1 equals 0, and then solve them. So cosine of theta equals 0. Again, the question is, what is that theta? If it helps, think about your unit circle. Cosine is the x value, so that would happen here at the top and the bottom, which would be at pi over 2 and 3 pi over 2. Remember, I'm listing all of the times it happens within that unit circle between 0 and 2 pi. For this one, I'm going to be solving for the sine of theta first. So I'm going to add my 1 over, divide by 2. And now I'm really asking where on the unit circle is the sine value 1/2, which would be at those first 2 dots there in quadrant 1, and then the other one over here in quadrant 2. So at pi over 6 and 5 pi over 6. I am fine with answers written like this. You might also see them written as theta equals, and then kind of going through all of them from least to greatest. So pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. Says the same thing, it's just how you want to list them out. For our second problem, we are going to find all solutions. Notice that I did not give the restraints of between 0 and 2 pi. I'll show you what that means in just a second. This problem is cosine of theta plus 1 equals 0. So I just have the one trig function. I can just subtract my 1 over. So I have cosine of theta equals -1. I'm going to still think about my unit circle. Cosine is the x, so that would happen over here at pi. So theta equals pi. This would be my answer if the question had said for all solutions between 0 and 2 pi. But the problem said for all solutions. So what you are going to do, if I think back to cosine when we graphed it, it has a period of 2 pi. So I could add 2 pi to this, I'd be at 3 pi, and I would still have a cosine that's -1. I could add another 2 pi and be at 5 pi, and then 7 pi, and so forth. So my answer for all solutions is pi plus 2n pi, where n could be 1, 2, 3, it could be -1, 2, 3, but I'm adding or subtracting 2 pi. That is my answer when the question says all solutions. Again, it's the 2n pi because that's the period for cosine is 2 pi. Let's do another one that is all solutions. This one is going to be 2 times sine of theta equals -1. Again, I only have one trig function happening, so I don't have to worry about factoring out anything like that. I can just continue to move things away from my sine of theta so I can isolate that. I have sine of theta equals -1/2. Going to think about or look at my unit circle. -1/2 would be at these two dots, 7 pi over 6 and 11 pi over 6. Again, that would be the answer if I had said between 0 and 2 pi. The direction set all solutions. So I'm going to have 7 pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. We're going to do one more. Sine squared theta plus 2 cosine squared theta equals 4. When I have multiple trig functions happening, I do need to try to get either where they have something in common, like on this first one that I could factor out, or I need to make my trig functions match. Because the cosine squared has the 2 with it, it looks a little bit uglier. I'm going to focus on my sine squared. I'm going to change that to 1 minus cosine squared using my Pythagorean identities. Plus 2 cosine squared theta equals 4. Well, negative cosine squared theta plus 2 cosine squared theta would be 1 cosine squared theta. So I really have 1 plus cosine squared theta equals 4. Subtract my 1 over. Cosine squared theta equals 3. Square root both sides. I'm going to get cosine of theta equals plus or minus the square root of 3, which when I'm thinking about my unit circle, I know we have the square root of 3 over 2, but I don't have just a square root of 3. Let me think for a minute. If I was going to graph cosine, okay, that was the one, like it went from 1 down to -1. At no point does cosine ever actually reach the square root of 3, because that would be more than 1. So that's going to be no solution.